All right, this next test, the root test, is certainly, it parallels the ratio test in that we are going to get out, we're going to take a limit of a certain expression, and then we're going to take the answer to that expression, and we are going to compare it to 1, and that's going to tell us whether the series converges or diverges. So exactly the same sort of conclusions and procedure as the ratio test, but the actual expression that we are computing the limit of is different. In this case, it is the nth root. And because of this square root term, nth root terms, an nth root doesn't simplify a ton of things, but it does simplify things that are raised to the nth power very nicely. So I will say that the ratio test, you are going to find yourself using that about 99.99% of the time, unless you have an easier test at your disposal. But you'll find that the ratio test is extremely powerful, and its applicability is very wide, where the root test in this case, it has a fairly narrow range of applicability, and it really does only work well when your series term, everything in it is being raised to the nth power or something related to the nth power. So fairly narrow range of applicability. Okay, so let's go ahead and again, like the ratio test, we don't have to go over the proof of that. We really just want to go ahead and use this. So in this case here, our a sub n term, example 3, is -2 to the n over n to the n. So this is an alternating series. But notice here that everything is being raised to the nth power. All right. And for the root test, we take a look at the limit. Let's not forget that limit there. It's fairly important. The limit as n goes to infinity of the nth root of the absolute value of this expression. All right, so a quick little fact here. Oops, close the absolute value bars. So a little fact is something raised to a power. If you take the absolute value of that, it's exactly the same thing as if we interchange the exponentiation and the absolute value. If we change that order, it is equivalent. So essentially, we could immediately think of this as -2 over n absolute value to the n, in which case the absolute values will act on the -2 over n, making it a positive 2 over n to the n. Now, of course, the nth root will cancel with this absolute value term being raised to the nth power, so this will turn into the limit as n goes to infinity of 2 over n. And as n goes to infinity, we get 0. We get 0. And since we get 0, this is less than 1. So the ratio test implies that the series converges. Again, just like the ratio test, the root test tells us not just convergence, but absolute convergence. So this converges absolutely. Example 4. Determine whether the following series converges. So this one, again, we can let's just jump to the expression, to the ratio, or to the root test, excuse me. So the nth root of the absolute value, and remember, we can exchange the absolute value and the exponentiation. We can flip that order, so we can get rid of this n and make this absolute to the nth power. So let's write it like that. So then simplifying this, the nth root will cancel with this being raised to the nth power. So we'll have just 6n over n plus 1. And this limit here, we'll take the ratio of the dominating terms. So that's 6n over n, which is 6, which is bigger than 1, so the series actually diverges. Okay. Another thing to keep in mind here, we didn't actually have to use the ratio test for this one. For me, and we'll talk about this next, is that when I approach a series and I'm trying to determine whether it converges or diverges, of course, maybe we recognize it immediately as a geometric series or a p-series or a telescoping series or something like that. In which case we know what to do in those cases. But if you're presented with a series that is not it's not purely geometric, it's not purely a p-series, it's not telescoping, it's some expression that maybe has aspects of all of those series but isn't purely that type of series, then we sort of have to think about comparison, limit comparison, maybe integral test, maybe root or ratio test. Those are all tests that involve potentially could involve a lot of steps and a lot of algebra. The divergence test is a quick way to check to see if your series converges it determines if it diverges. So if we take a look at this and we apply the divergence test to this, which is one of the first things I think of, we just take the limit as n goes to infinity of this expression. So what we see is the inside of this expression approaches the value -6. So the inside here is -6 in the limit sense, and then this exponent, didn't mean to erase that approaches infinity. So what's important here is that every whole number is either even or odd. So when n is even, the expression on the inside, no matter what size it is, it's going to end up being a positive because I'm going to multiply it by an even number multiply it by itself an even number of times. But when this exponent n is odd, I'm going to multiply the inside value here, a negative number, by itself an odd number of times, which means it's negative. So I don't want to say half of the time it's positive and half the time it's negative, but that sort of informally communicates the idea. So because of this, it's sort of flip-flopping. As n increases by 1 each time, this expression here flip-flops signs. Positive, negative, positive, negative, positive, negative. And because the inside here isn't approaching 0, it's approaching some positive number, in this case 6. Well, in absolute value, it's approaching positive 6. This sort of means is in the limit, we can sort of think of if this is the line y equals 0, then down here is y equals -6, and up here is y equals 6. So if we're at like n equals 1 billion or something like that, then it's more or less doing this. So the limit clearly doesn't exist. It's not honing in on one unique number. So this limit here simply does not exist. Which means the limit doesn't exist, and if it doesn't exist, that means it clearly can't be equal to 0, which is a number that, well, exists. So by the divergence test, this implies the series diverges. So to me, this is quicker than applying the root test. So yeah, just keep that in mind.